Hi guys, it's Mrs. Williams. Okay, so today we're going to look at factoring. We're going to look at two types of factoring. We're going to look at factoring out the greatest common factor, and then we're going to look at factoring the difference of two squares. So make sure you're all settled, make sure you have your notes, make sure you've checked your tech, and here we go. Okay, so remember factoring is simply the reverse of distributing. Okay, so if you have your distributed version and then you have your factored version, notice here 5x squared plus 15x, a 5 divides into both the 5 and the 15. The x squared and the x, and x goes into both. Okay, so in each of these examples, 2x cubed minus 8x squared, there's a 2 that goes into 2/8x. There's an x squared is the greatest common factor. So all of these numbers outside the parentheses, those are the greatest common factors. And if you were to distribute them and multiply, 5x times x is 5x squared, 5x times 3 is 15x. So you can check your factoring by multiplying, and you'll know that if you came out with the original problem, you'll know you did it correctly. So when it comes time to find the greatest common factor, you're going to compare all your terms. You're going to find the GCF of the numbers first. Then you're going to find the GCF of each variable. That will be the smallest exponent the terms have in common. The smallest exponent the terms have in common. Note, if the first term is negative, factor out the -1. That's going to be key and really helpful down the road, that if the first term is negative, factor out a -1. Okay, so let's try some here. Let's factor out the greatest common factor. And I know I said factor out, find the greatest common factor for the number first. It really doesn't matter if you do the number or the variable first, as long as you do them both. So let's take a look at 18x cubed and 27x squared. If we look at 18 and 27, what's the biggest number that divides into both 18 and 27? That would be 9. So we're going to divide. 9 goes into 18 2 times, and we keep the x cubed, plus 9 goes into 27 3 times, and we keep the x squared. Okay, now we're going to take a look at the greatest common factor for the variables. So the variable is x, and we have an x cubed and an x squared. Which is the smallest exponent? The squared. So we're going to divide out an x squared. Now remember, when you divide, what do you do to the exponents? Well, we keep the coefficient 2, and we subtract the exponents, right? Remember that we subtract the exponents. X cubed divided by x squared, 3 minus 2 is 1, so we have x to the first. Plus, we keep that constant 3. X squared divided by x squared is 1, or 2 minus 2 is 0. Remember, x to the 0 is just 1, so we don't have to write it because the x squareds basically cancel each other out. Now the final step, see these factors that we had out here? We have to multiply them. 9 times x squared, that's 9x squared. And then we bring down this 2x plus 3 that we had left out over after our division. And here is our factored form. And that's it, guys. That's the whole kit and caboodle. Let's try another one. We've got 16x squared minus 24x. Let's say this time we do the variable first. All right. So our variable is x. This one has an exponent of 2. And this one, if it doesn't have an exponent, remember it's 1. So the smallest exponent is 1, so we're just going to divide it by x to the first. So we keep the constant 16. X squared divided by x is x, minus, we keep the 24, and x divided by x is 1, so it goes away. Okay. Now, let's look at the constants. 16 and 24, I know what goes into that. 4 goes in there, right? 4 goes into 16 4 times, keep the x, minus 4 goes into 24 6 times. But you know what? There's something that goes into 4 and 6, isn't there? Yeah. Turns out I didn't use the greatest common factor. I didn't pick the biggest number that went into 16 and 24. But hold on. we're looking at this and saying, oh, wait a minute. 4 and 6, 2 goes into that. 2 goes into 4x, 2 times x, minus 2 goes into 6, 3 times. All right, now they have nothing in common. So now I'm going to look at all these numbers here. X times 4 times 2. That's 8x times 2x minus 3. Okay? So even though, and I intentionally did that, yes, we should have in this step, the greatest common factor would have been 8. We could have pulled out an 8 because 8 goes into 16 and 8 goes into 24. And 8 would have gone into 16, 2, and we kept the x, and 8 would have gone into 24 3 times, and we would have had fewer steps. But if you don't find the biggest one first, because sometimes that happens to us, we're still okay. All right, you just have to do it again. Now there's one more that I want to take a look at, because some people don't always see this, but let's take a look here. X squared times the quantity x plus 3 plus 5x times the quantity x plus 3. Now you see that plus sign, whether it's addition or subtraction, and it's not in parentheses. That separates the first part from the second part. Now if you look at the first part and you look at the second part, do they have something in common? Well, lo and behold, they do. They both have an x plus 3. That's a greatest common factor. And it's unusual to see it that way, but if we get used to this now, it'll make the tricky trinomial factoring a little easier. Now, in the first part, if we take out the x plus 3, that's going to leave us with x squared. And we bring down this plus sign. If we take out the x plus 3 in the second part, we're left with 5. And guess what? We have now factored by greatest common factor. Yay! Okay, let's try the next type of factoring we need to review. And that would be factoring the difference of squares. Notice I'm not saying the difference of two perfect squares. Please notice that. I'm not saying that. It's just the difference of squares. Now the first thing, in order to use this method, there's a few things that have to hold true. The first thing is the degree must be 2. So in other words, it has to be quadratic. Okay, this highest exponent of x has to be 2. The next thing, the number of terms also must be 2. It has to be a binomial. So notice there's one term here and then one term here. Okay, and the third thing that has to hold true is there must be subtraction. Notice this is a difference, this is subtraction, okay, and it has to be subtraction. All right, so that's important to realize. Now, so this must be a minus sign. If it's addition, it does not work. Can't factor it. Okay, addition, it's not factorable. Now, here we go. First thing you're going to do is you're going to take the square root of the first term. I'm going to make this a little bigger to write this. Take the square root, and this is going to go first in both sets of parentheses for our factor. Okay, so for instance, if we're going to factor 81x squared minus 36, the first thing we do is we take the square root of 81x squared. Well, the square root of 81 is 9. My computer is thinking. The square root of 81 is 9, and the square root of x squared is x. So we would write one parentheses with a 9. I said x, but I wrote x squared for some silly reason. Okay, so it's 9x, and I'm going to leave some space to close my parentheses open. I'm going to write 9x again. I'm going to leave some space, and I'm going to close my parentheses. Okay, now step 2. Step 2, we take the square root of the second, or the last if you prefer, term. This goes last in both sets of parentheses. So here we would take the square root of 36, and the square root of 36 is 6, right? So we would put a 6 here and a 6 here. Now the last step is to make one addition and one subtraction. So this would be 9x plus 6 and 9x minus 6. It does not matter which order you put them in. It will give you the same thing, because when you multiply When you multiply these two terms, you're going to get negative 54x. And when you multiply these two, you're going to get positive 54, and they're going to cancel each other out. Okay? So then all you have left is the 9x times the 9x. There's your 81x squared. And this positive 6 times a negative 6, there's your negative 36. Okay? All right. So let's try another one. Let's try x to the 4th minus 49. So the first thing is to take the square root of x to the 4th. When you take a square root of a variable, okay, you divide the exponent by 2. So the square root of x to the 4th is x squared. Because when you multiply x squared times x squared, you would add those exponents. 2 plus 2 is 4. So if you take the exponent of 4 and cut it in half, you're dividing it into the two pieces that you would add to multiply. So that means in our parentheses, we're going to have an x squared and an x squared. Then we're going to take the square root of 49. That's 7, right? So we have a 7. And we have a 7, and I forgot to close my last set of parentheses there. And then we make one positive and one negative, and we're done. Okay? I've got one more for you. Let's try this one. X squared minus 5. Now, if I take the square root of x squared, that's just x. Okay. Whoops. So I'm going to have x, right? Because I took the 2 divided by 1, and that's my x. And I have x. Now let's do the second term. The square root of 5. Wait a minute. What multiplies by itself to the square root of 5? Do you know how to find your perfect squares, right? If you want to know what your perfect squares are, by the way, just start doing it. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. These are ones you should know. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. You should probably also know for Algebra 2 and Intermediate Algebra, 11 squared is 121. 12 squared is 144. And 13 squared is 169. Okay, those are the perfect squares. Now notice 5 is not in that list. It's somewhere in between this 4 and this 9. Okay, it's not a perfect square. The square root of 5 is the square root of 5. We would put radical 5 and radical 5. Remember when I warned you, I didn't say this had to be the difference of two perfect squares. You don't have to know the square root. The square root of 5 is radical 5. So x squared minus 5, if I factor that by the difference of two squares, is the quantity x plus radical 5 times the quantity x minus radical 5. Now, I am going to be honest. In Algebra 2 in New York, you're probably not going to have to factor that, okay? But I teach calculus and pre-calculus, and those kids do it all the time. And they come to me and they've never seen that before. So I want you to at least have seen it. Okay? So, all right, guys. We now reviewed factoring the difference of two squares. Okay? Take the square root of the first, put it in the parentheses at the beginning. Take the square root of the second term, put it in the parentheses at the end. Make one positive, make one minus. We've also looked at the greatest common factor. Find the biggest number that divides into the numbers. Find the biggest variable. And you do that by using the smallest exponent on x. All right, guys, that's it for today. Make sure you think of your question for me, whether it's one you have an answer to or one that you don't have the answer to, or if you just need clarification on something. All right, guys, I'll see you next class. Have a good day.